there. Sorry. We're that again. Old dog, new tricks and such. Yep, a little difficult. So anyway, yeah, I just thought I would do this, and I felt like it. Which doesn't make much sense, but as a reason to do a room anyway. Just evading working, mostly. Mostly. No, I mean doing less pleasant things, let's just say. So Ken did make another video, so I guess I'll just sort of make a habit of, um, you know, ragging on whatever he says regarding physics, in some sort of nasty kind of way until he mans up and accepts his obligation to defend his physics in some sort of real-time interaction. Where he isn't always got the huge advantage of a text stream that flies by at 25 comments per minute or whatever. Anyway, so we'll play. I mean, just making mistakes is okay. About, say, if you were coming up with something new and you were adding something new. Okay, this is going to sound convenient, but I'm just saying, quite obviously, if you're developing a theory, you could say, okay, it's okay to have a couple mistakes, fix a few equations, that kind of stuff. That's always happened in history. But when you're going to make statements about Roman arches, I mean, things that are hundreds, if not thousands of years old, you sort of have an obligation not to screw that one up, I think, if you're gonna pontificate on it as if, this is, he keeps doing this, the missing secrets, the lost secrets of the ancients kind of stuff, like there was some sort of, some sort of great knowledge that we're all missing out on. And boy, you just wait till we refine that stuff. We're going to have all kinds of cool things like, flying garbage cans, like Dick Tracy or something. Who knows what else? So just great fun, just can't even imagine the mess that something like that would actually make. How the hell would you ever regulate it and such? So anyway, so we'll play some of his video. I suppose that's the way to go. So I guess we'll do the screen share thing and ruin the sync of the video, but that just adds to the charm. Again, a rationalization, but their rationalizations are quite convenient when they're not too meaningful. Look at all these things I have a choice of. Wow, task manager. Wow, I can put almost any kind of crap into this screen share, but we'll put the crappy video in, and well, that certainly doesn't look right. I hit the right button. I'm damn sure I did. It doesn't look right. No, it just isn't right at all. It's at the camera instead of what I was after. All right, technical issue. My bad. I hit the wrong icon, apparently. That's what we're looking for. Let's see if we make it a little bigger. Well, apparently it's a little bigger, maybe. Anyway, see how it goes. So right off the bat, he just starts off with this more of this hyperbole. I mean, just way overstated. Just so much like the propagandist of past and present. I mean, just so much of the game of the hysteria, almost a hysterical physics.
Okay. How would you like to learn the secret of all future technological developments? Okay. All goes back.
All future technological developments. I mean, why would you even say something like that? all of them, every single one of the new future technical developments. Come on, it's just a silly thing to say.
The ancient Romans and their arches.
So now it goes back to the Romans. So before it went back to the Greeks, and it goes back to somebody. And I mean, I can't believe that he's going to bring up Roman arches. I mean, it's just such a wow. Didn't you do that one in sixth grade? I mean, really, sixth grade, you learn that, okay, you put a bunch of bricks into an arch, and then instead of the pressure being down, the pressure goes sideways. Wow. I mean, it's really clever they figured that out, and it's really neat that physics works that way. But this is going to be the future of all new technological advancements, this reapplication of the Roman arch. I mean, get serious. I mean, this is an extraordinary claim. I put this almost in the UFO category. And if you're going to say shit like this, you really ought to back it up with something.
Okay. Now there's three, like weight, for example. Most people think weight is something like, I weigh too much, right?
Yeah, you do. Uh-huh. I listened to his live room the other night, and he went out this whole piss about this girl who's been, doing the anorexic thing for fun. And, it's just kind of funny that he just keeps talking about how, terminally ill she is, and she's not really. And, he's a walking heart attack, statistically. It's called morbid obesity, wake up. And I'm only pointing this out just because he's just so closed-minded for somebody, again, who's not exactly in a position to be closed-minded, in terms of having somebody understand his problems and his psychoses and all of that shit. And it just seems just pathetically hypocritical. I mean, the hypocrisy is pathetically obvious. Well, anyway.
Obviously, I weigh too much. Weight. They think, well, what is weight? That's acceleration of one body towards another, where it's actually mutual.
Well, whatever. That's one interpretation, but obviously we do have a scientific, in physics, and that's what you're supposed to be talking here. They have an idea of atomic weight. So they have an idea that having certain constituents of material elements will dictate your weight in all circumstances. It's a universal comparison. So you can use this atomic weight thing, this number of protons and electrons, to define what you're likely to weigh, in the sense of what kind of effect gravity is going to have on you, and what kind of effect your mass is going to have on another mass, which is also important to weight in terms of your collective momentum. How easily you will acquire velocity based on the fact that any acceleration has to be spread over your entire atomic weight. There are certain consistent rules to that, and doing this little mushy, how much do you weigh when you're on the surface of a planet, isn't really getting to the subject entirely or explicitly.
Acceleration. Weight changes even if you climb to the top of an extremely high mountain. There are actually gravitometers which detect the differences in 1G of gravity variances on different places of the Earth.
Yeah, well, those are more likely detecting the differences in air pressure. Obviously, air pressure has something to do with scale pressure in terms of what your weight is going to manifest as, because we're in an atmosphere, and obviously the medium changes our what our natural weight would be in a vacuum versus what your weight will be in a medium, where there's different densities of the medium above you, compressing you, pushing you.
Earth, like if you go over the Marianas Trench, the gravity changes. If you go to the top of a mountain, your weight actually changes. Not that you should climb to the top of Mount Everest with a scale. Weight,
Yeah, I just don't. You're saying they can measure it up to a mile out of a 4,000 mile diameter. I'm not too sure they can do that, but whatever. I'll concede the point, but I won't argue the point. I mean, they can with good enough tools. They can measure the difference from like 10-story building. But
is location specific, vector specific, medium specific, and geometry specific. Well, what the hell does that mean?
yeah, well, this vector thing doesn't mean much, frankly. I mean, obviously, you're not going to have any weight if you're, moving 70 miles an hour away from the scale. And obviously, if you're moving 70 miles an hour towards the scale, you're going to weigh a hell of a lot more than your actual weight. So I don't see what that has to do with this.
Without getting into an extremely long discussion.
Well, it'd be nice. Long would be okay if there was actually a detail in here somewhere. Where an actual detail was correct, then it would be worth it. But because all the details are incorrect and there's all this ambiguous mush, it really isn't worth it. No matter how long it is, it isn't worth it.
Okay, we obviously know that weight is location specific. If you weigh 100 pounds here on Earth, you're pretty skinny. Now, you weigh 100 pounds here on Earth. If you're 100 miles out from Earth, your weight is going to be, not to be that far. Let's say the top of the ionosphere, your weight's going to be radically different. So,
see, again, no, it isn't. No, you have to go much further than the ionosphere. You have to literally go thousands of miles before it's going to be radically different. I mean, the inverse square law is powerful, but it's not that powerful. I mean, you actually do have to go twice the distance to have 1/4 the force. But I mean, that's twice the distance. So a mile or 2 miles or 100 miles isn't really going to be radical. Unless you have a velocity, of course.
But we know that weight is location specific. Vector specific.
Again, it just doesn't mean anything to say location specific. It's not going to matter your location in the sense that you can have lots of locations. It'll be exactly the same weight, depending on where those locations are. If it's a sphere, then all kinds of spherical locations will have exactly the same weight. So I don't even know the point of this dependency. I mean, to argue that you're two things in the same environment, the weight is going to be relative to each other and relative to the circumstance, yes. But again, it isn't that obvious. Who are you spelling that out to? You can't weigh something if you're moving away from the scale. Well, yeah, you can't weigh anything.
Specific. We also know that if you actually change the vector of approach or the point of acceleration towards the Earth, for example, that the weight varies. If you actually take a curvilinear path towards the Earth,
there is no curved linear path. You could take a diagonal, you could say, but there's no curved linear. So, but anyway, yes, if you took a diagonal path, the truth is your path is made out of two vectors. And the truth is that one of those vectors would have to be smaller for there to be an effect. But the point is you're either going to weigh more or you're going to weigh the same, but you can't really weigh less in that circumstance.
The actual weight displacement changes. Same way a block and tackle works and a gyroscope works as far as displacing the vector of the weight of acceleration. You can actually spin up a super heavy gyroscope and lift it with ease, but if it's not spun up, now people incorrectly tell you that the weight doesn't change, but it actually does.
Okay, it actually does, and you have the experiment where, and so why don't you just point to it? Why don't you just link to the YouTube video of some guy holding the gyroscope and without playing any other game, weighing more than the gyroscope in himself.
Actually twirl the gyroscope at a specific vector, it will move in opposite direction to the point of acceleration that accelerated towards the Earth, while your weight doesn't change.
Yes, right. You can jump up and down on a scale also, and that will make the needle go up and down. You can go up on your toes and heels, toes and heels, and you can screw up your scale. But screwing a scale up isn't quite the same as having a change in your atomic weight.
If you're spinning up a gyroscope, has been proven, while you're standing on a scale, it's true, the weight is the same. However,
Okay, so now he concedes the point that he made before he argued against, and now he's saying, yes, the weight is the same, but however, if you jump up and down, it'll go heavier. Yes, that's right, if you jump up and down, that is, you you fight against the inertia. Okay, that is, you try to accelerate something while you're on the scale. That's right. You're going to sit there and appear to be heavier, but you're accelerating something while you're on the scale.
Notice if you spin it in a curvilinear fashion away from the Earth, you'll actually notice that the scale will radically change. We do know.
Right. And if you put your weight on your toes and then back on your heels, you can also fuck your scale up pretty good also. Yes. Amazing. Wow. Gee, how could nobody have figured that out in all this time? Oh, wait a minute. They did figure that out. Yeah.
For a fact that weight is okay, location specific, vector specific.
I'm going to get to there's a part here that gets really stupid, and I'm just waiting to get to the really stupid part. Sorry. I mean, this is stupid, but the really stupid part is yet to come.
Medium specific. How easy is it to define weight as far as a medium? Say someone as fat as me. There's no way like a little 5-year-old girl could move me around sitting here in the room, right? No.
Well, I'm pretty sure your chair has wheels on it, so I'm pretty sure she could.
Impossible. You stick me in the middle of water, she can move me around, no problem at all. So
just about the same thing as the wheel argument, in the sense that you have no friction when you're in the water. That's really the game. Buoyancy just, eliminates all the friction.
Oh, I'm actually suspended in the water. Well, weight remains the same. You weigh the same regardless. No, we're in a different medium. Well, you weigh the same in that medium. Oh, really? You place a scale underneath?
Yeah, well, you have to have a different kind of scale. So obviously, if you change your scale to be capable of compensating for buoyancy, then you could measure your actual weight, that kind of thing. So you just have to understand scales have to change when you're in a different medium. But again, when most people in the scientific community are talking about weight, they usually mean to talk about it in some sort of default condition, not complex condition. So you talk about it first in the vacuum of space kind of circumstance.
To me, while I'm standing in the water, I guarantee you I have a totally different weight.
Okay, and so I'm sure everybody in this audience doesn't know that, and so it's good you inform them, because obviously your viewers are imbeciles and they need it explained to them that they can float in a bathtub. Yes, they didn't know that.
So weight is location specific, vector specific, medium specific. It is also geometry specific. Now let's talk about the two things as far as field.
You just threw that one in there just for fun. Geometry specific. Okay.
Coherency and magnetism, and also in light. Now, most people don't know what the term coherency means, but let's first talk about the geometry of weight, something the ancient Romans discovered ages ago. Everybody knows about Roman arches. I hope to God everybody.
Yeah, right. And you didn't really add anything in this discussion at all. You just, I hope to God you understand arches, because I'm going to sit there and basically go even further into I'm going to give you not just the 6th grade explanation. I'm going to go down to like 3rd grade explanations. No details at all, though.
He knows about Roman arches. It isn't.
No facts.
Known absolute fact that if you take 2 slabs of concrete, I think they're like 12 inches in thickness, both absolutely the same, one of them completely flat, and you span a distance of, say, 3.5 feet, you take the exact same thickness and you make a half circle out of.
So he just did it right there, right? Straight line diameter, and then he did, all right, you make a curve. Same thing, same distance, same thickness. You can't make errors like that. And the whole video has that same arrows repeated like 7 times. He implies that you can have something that has the same thickness, the same length, the same strength, and you can have it like diameter and circle. And circles don't require a lot more material, at least half as much material. I mean, it's the pi thing. 3.1, 3.1, whatever the other number for. Yeah, you need 3.14 for a whole circle. So for half a circle, that would be 1.6 something.
But you span the exact same distance. It is a known fact that the curved arch, because of its geometry, hence Roman arches in the Colosseum and the aqueducts, why are they curved? Not only does it require much less material to support the same weight, it also displaces and holds itself more weight. This test has been proven over and over and over again.
Yeah, but it does depend on the material. Quite obviously, things that are crushable, it's less strong. So, things that compress easily. So it's really compression strength that becomes the what's valuable.
You can stack over 4 times as much weight on the same thickness of concrete.
So again, he said same thickness of concrete. Now he just did say, well, you can make things much thinner and lighter. And now he's back to, no, it's the same thickness. No, it's not the same thickness. You should have said maybe the same amount, and then that might have made sense. You can use the same amount of concrete. But frankly, I don't know if it's going to work with just poured concrete. You'd probably have to have reinforcement in concrete.
In a semicircle, i.e. an arch, than you can over the same thickness of concrete that's flatly spanning the same gap. You stick 2 tons.
Same thickness, 2 tons.
Over top of the flat, it will break right through. You could stick something like 8 tons over top of the same concrete arch, and it is still holding. So
right. So again, the arguments can be different arguments. You make different arguments about why this works. But I mean, obviously, one of the most important arguments is that's why they have the word keystone, is the shape of the stones is permitting you to spread the force in the horizontal direction. So you're pushing sideways instead of down. So you're converting the gravity from a downward force into a sideways horizontal force. And so more of the material is involved in the support of the structure. You're just spreading the weight.
Over 4 times as much weight over the exact same concrete that weighs the same and is the exact same thickness.
See, it can't do both of those. It can't weigh the same and be the exact same thickness. It just can't do that because it has to be more material. That's part of the reason why the arch works too, is because it's more material that the force is pushed through. It's 0.67 whatever more material. And you're sort of just ignoring that part of the equation.
This is the old question: is when is 1,000 pounds of concrete not the same as 1,000 pounds of concrete? The mixture is the same, the weight is the same, the thickness is the same.
There, okay. See, that's what you can't do. You can't do the thickness is the same thing. That's just not going to work. Circumference bigger than diameter has to be that way, even in counter space.
Everything about this slab of concrete is exactly the same.
Okay, that's a word you really shouldn't use when things aren't exactly the same. So, I know sometimes we all use that kind of word because we're saying, look, there's no difference that matters. But these are differences that matter. So in this circumstance, you really can't do this lazy guy thing and just say, oh, it's the same thing. It's exactly the same. Well, no, it's completely different, really.
And I think we understand that really quickly, okay? What does that mean? This is something the ancients discovered a long time ago. It means if you have 2 different...
Right, and he says this is going to be our future innovations is based on this observation made a long time ago that, yes, if you spread the weight over a broader area of the material, then it can do less destructive damage to any one portion of the material. And then if all the weight ends up being focused on one part in the material, then it's more likely to fail. And you also make an argument that if you extend something over the edges further, you cantilever something further over a surface, it'll also become stronger. So there's lots of things that'll make something capable of supporting more weight. But you're not really going into the physics of any of that. You're not going into the physics of stretch and tension and the mechanics that actually makes all this work. You're just, yes, you're not even doing a good overview.
materials for suspending or supporting something. They're both the same weight, the same strength, the same thickness, the same length.
Keep saying this over and over again. So you've seen Ken videos by now, right? So you get the pattern. He just keeps saying the same shit over and over again. And what he's saying isn't rational. It's not sensible to say it that way, because they can't be the same thickness and the same length when a circumference is bigger than a diameter. It's just, you can't say the same length. It just doesn't make any sense. Obviously not the same length.
That one will hold over 4 times as much. This is not a belief or a theory. This is a damn fact. It will.
Well, I don't even know if it is a damn fact, because again, if you took something like a piece of railroad, a piece of steel, and again, if you spread the majority of its mass over the surface and have only a small hole for it to gap, a small gap for it to cross, and then you bent it into an arch, I'm just not sure you're going to get that 4-to-1 ratio.
Hold over 4 times as much weight if you curve it. This is where weight is also geometry specific. So weight is location specific, vector specific, medium specific, and geometry specific.
Well, again, the argument that it's geometry specific, this doesn't have anything to do with the weight. It has to do with the tension of the thing supporting the weight. So again, what does weight have to do with this? It has nothing to do with it. So again, another hugely inaccurate way to describe this. This has the ability of the material to spread the forces, has absolutely nothing to do with necessarily any conversation about the weight of something. Its weight doesn't change. The ability of the bridge to support the weight has changed. I mean, huge difference.
Specific. This is also how future there's no such thing as anti-gravity. Gravity is nothing other than incoherent.
No such thing as anti-gravity. Good, I'll agree with that. But this part I won't. Gravity is nothing but incoherent, blah, blah, blah. And the stuff we do see is apparently coherent. So the incoherent stuff is invisible. Okay, so I could say the unpolarized stuff is invisible and the polarized stuff is visible. So we might have something to agree on right there. Something worth talking about, maybe in a live room, if you weren't a coward.
Dielectric acceleration, that which people call magnet.
Yeah, dielectric acceleration. I can see the existence of accelerations, but I don't know what the old dielectric is.
Magnetic attraction, which is coherent acceleration.
Right, so the gravity is incoherent and the magnetism is coherent. So yes, polarized versus unpolarized would be my version of that. Polarization versus the absence of polarization. That will define the difference between gravity and magnetism.
Gravity is nothing other than incoherent acceleration. Okay?
Yeah, okay. I hear what you're saying, but I don't see what you're saying. So to just say there's incoherent acceleration, I don't know what to make out of that. Acceleration how? By what? Through what? Where? What?
So weight is location specific, vector, medium, and
vector, medium, again, so he's doing all this thing about weight. And again, we know this isn't about weight because he just now talked about the carrying capacity of materials. And the carrying capacity of materials is not the subject is not how much does something weigh. Subject is how much can it carry.
Geometry specific. What are the two principles that are going to, and then finally a third principle that are going to redefine everything as far as human technology is concerned? Two things. Field coherency. People don't know what coherency is. People think.
Yeah, redefine everything. Again, is this just insane rhetoric? I mean, everything's going to be redefined by this? I don't think so.
Well, like coherent light amplification by stimulated emission of radiation, i.e. coherent radiation. Oh, that just means that all the waves of a certain frequency of light are all operating, within the same phase. No, that's a description. That's not actually an explanation of what's going on.
Well, whatever. Obviously, it would all have to be light of the same color to be in phase anyway. Yeah, so they use a lot of different words, collimated light, colliminated light, coherent light. So yeah, it does get a little bit, yeah. But yeah, I think that's the more important one is when light's parallel. That's the more interesting phenomenon.
And there's incredibly intricate articles as far as what is coherent light, what defines it, but the ultimate irreducibility of it is, and that's going to be in my next edition, or the fifth edition of the book, is the same thing that defines field coherency in a magnet. That coherency is point specific emanation. In other words, in a laser, people say, well, light's bouncing between two mirrors, 100% mirror, and that's in a regular, like helium neon.
Whatever, point specific. Again, and what is this point specific? When you don't think there are any points, any elements, how do you get this point specific happening when there are no constituent fundamental particles to be points in the first place?
A conventional mirror, not like a diode laser or a chemical laser. There are many different types of lasers, but all lasers operate off of the coherent radiation, the same principle, which is point specific emanation. Now, in the magnet, there's absolutely no.
So again, point specific emanation is so my understanding of lasers is that it's just the multiplication, in a sense, a type of multiplying of the initial energy that stimulated the creation of the photon, and by recycling that energy you can create more light. But that's just my understanding.
Change in the quantification of a magnet before it becomes a magnet than after it becomes a magnet. That ceramic block of neodymium iron boron or samarium cobalt or ferrite is exactly the same before it's a magnet than when it becomes a magnet. Pulses and
so again, he says it's the same thing again. He says it's exactly the same. And again, this is one of those points where you have to say, well, you can't say that. It's not rational to say that. It's quite obviously not exactly the same because it's clearly changed when it becomes a magnet. So when it's magnetized, something happens to the structure. It can't be exactly the same. It's silly to say it's exactly the same. Even, I don't know what theory of physics you have where something can be exactly the same yet fundamentally different. It's well, how does anyone make sense out of that? No, nobody rational can. All right, so I think it's enough for now. But yeah, it's just really sloppy rhetoric. It's very, very sloppy for somebody pretending to do physics and pretending to know something about physics, which you'd have to know that throughout the whole history of physics, people were required, if they have a theory, they were required to make it account for other things, the phenomena they knew existed. They couldn't just come up with some theory and pretend all the experiments that had been done hadn't been done yet, and they could just make up some new theory and make new properties and new events and new things and just pretend nobody already knew certain rules. And so they always had to make their thing fit into the existing rules. And you're not paying any attention to that at all. At all. Anyway. Enough. So, let's see if there's any commenters yet? No commenters. Excellent. Yeah, I won't have to read them anyway. Yeah, and block them usually anyway, right? So, eh. So yeah, so the purpose of me, like I said, I just going to try to be a pain in Ken's ass, and oblige him to, grow up past his 9-year-old mentality and recognize that if he is if he's being honest about his confidence in his discovery of the truth, then he should be willing to defend it. And yeah, and if he thinks everybody else is an imbecile, then he should be comfortable with the idea that he can prove them to be imbeciles, rather expediently and be done with it. But I don't think he's going to be able to do that. It would just be nice to get to first principles. I mean, just get to some overview to recognize where Ken's coming from, because it seems like there's a coming from, in my opinion. I mean, you don't sit there and preach this stuff like it makes a huge amount of sense, unless you have some sort of reason to be doing that when it doesn't make a huge amount of sense. I mean, when it isn't a roadmap that you can draw a picture of. And you can't draw a picture of it. You can't draw a picture of attraction and repulsion. You can't show it to you physically. Where I, of course, can, by just drawing a few arrows. Yeah. Anyway, so that's sort of the first thing. That was the beginning, the first principles, and the idea of, you would argue that you're looking for a simple solution. Now, he claims he has this simple solution. So this is just one of his statements, though. He says, he mocks conventional physics as, with all its mathematics and its particles and, as being too complicated. It's geometry even. So he uses these analogies like Mother Nature isn't a crack whore with a calculator or some kind of crap like that, implying that there's some obligation to keep it simple, stupid. And yet, what is simple about the 75 syllable words he throws together to describe his he just used the word, right? Incoherent perturbation in counter space through hyperboloid momentum mediation or something. I mean, what is simple about that? How is that a simple description of anything? I mean, how could that be ever described as simple? So I would say that my argument of the simple, that the universe begins with things moving the speed of light, and those will become everything. But most obviously, they'll become the forces, and that would include light. So all the stuff moving the speed of light is made of the same little bits moving the speed of light. And then we can just start to give those things a little tiny bit of property, in terms of having polarization, having a shape. And then there's a simple rule that in a circumstance where there's an interaction between things of different shapes, that the shape will change direction. The momentum goes straight through, but the polarization doesn't. Or you can look at it vice versa. You can just say the momentum changes and the polarization stays. Either way, it doesn't really matter. I mean, the effect is the same. One changes, one does not. One goes through the interaction, one turns, one reflects. So you have this idea of a reflection. So that's your simple first principles. Stuff moving the speed of light, and it's capable of reflecting and it's capable of leaving behind through that reflection um, its momentum. The thing it hits goes the direction it was going, and it goes the direction the thing it hits was going. So, yeah, not complicated at all. That's the simple answer. What about the tangential vectors mentioned in the Hyprax-Tolson theory? Well, obviously the tangential, which would be perpendicular, um, is also mentioned by Maxwell. So, I mean, that's already a stated, that's like a fact you can't undo, that the energy transfers are perpendicular. The polarization momentum exchanges are also happening in perpendicular interactions. So there's two ways a quanta can hit another quanta when matter is involved. And when matter is involved, they can hit uh, tangentially, which is perpendicularly, and there can be a 90-degree change in the direction instead of 180 degrees. Well, anyway, I don't think there's any way to ever prove that. I think that's bullshit. Well, again, the proof is in the fact that it unifies all the forces. So that, in my opinion, is a pretty substantial proof. The fact that it explains time dilation is another substantial proof. The fact that it explains why things moving continue to move, inertia, which has been explained by no one ever, okay, is a pretty substantial piece of evidence on its side. Now, the fact that I may someday prove that the two-slit experiment is a fraud by aiming photons or even aiming electrons, and demonstrate that the experiments fundamental to wave theory are nonsense, that I'm certain I can prove tomorrow, okay, I think, that Huygens is a made-up pile of shit, and that there's no two photons in the single-slit experiment for certain. But whatever, the proof will come. I'm just saying theoretical physics doesn't quite work that way. I guess you don't know too much about it. But Einstein wasn't falsely proven correct until 10 years after he established his relativity theory. And he was proven correct by a bad experiment. So ironically, he was never even proved correct. So you obviously don't know anything about physics and how it works. Oh, you have a theory of inertia. Well, maybe you want to come into the room and defend it. Or maybe you have a paper written somewhere, or maybe you have a video somewhere. I really don't think you're probably not going to be able to explain it in the text box. So why should I be impressed for some reason? Yeesh. His name is Jeebus, Anal, Anna Leitz. Don't know what that means. So anyway, but clearly a snarky asshole. So anyway, let's go to Google and look up hypertension theory. Sounds like heart attack theory. Hyprax torsion theory. Let's see, I'll go with images first, right? Images say everything. It's got rats and voles. Let's see, a fish skeleton. A funny looking Japanese guy. Yeah, lots of funny looking Japanese guys all of a sudden. There's a funny looking American guy. Volcano, well, not very helpful. I guess I should put the screen share on for this one. But yeah, it doesn't look like it's much of a theory because there isn't shit worth of fucking goddamn images associated with it. So I'm not going to worry about that theory. Thanks, but no thanks. Hey, where's the right window here? Do, 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 do. What happened to my window? Oh, I changed it to Google. Quite correct. All right. I don't think you're in the right mind to understand what I have to offer. Well, then fine. Just fuck off. Thank you very much. Goodbye. Ugh. Yeah, right. I'm the one with the broken mind. People. Assholes, all of them. Sorry to say. I mean, just so many are assholes that you might as well just say they're all assholes. Okay. So where was I before rudely interrupted by the retard? All right, so the whole simplicity thing. So here we got this simple mechanism, um, made of very few rules. Two rules maybe in terms of interactions. Head-on collisions create reflections when unlike polarizations hit each other. When like polarizations hit each other, the interaction is theoretically invisible. The outcome is indistinguishable. Whether you believe they missed each other, or whether you think they hit each other, it doesn't matter because the outcome will look exactly the same. All right, then we have this other idea that push is a lot simpler than pull. So this is just an idea confirming this mechanical simplicity of things hitting each other because it really is kind of obvious. It's really easy to hit something. It's really complicated to make it come towards you, you know, to in some way force it to move towards you. Um, yeah, pull just doesn't have any. It doesn't have any. There's no way to make a simple description of a simple pull mechanism. Vacuum cleaners are complicated. I mean, they're certainly more complicated than bowling balls, and cannonballs, and any kind of ball moving. And the fact that it would collide into something, you really can't get any simpler than collision. Let's see, Mr. Hertz. Am I correct in assuming that physics has a direct relation to ethics in regards to determinism? No, I don't think so. Science is science, right? You're describing the truth. So whether you're doing physics or you're doing philosophy, your object is to create accurate statements, period. You want to accurately describe how the thing works. And philosophy or ethics is just an attempt to accurately describe what's the meaningful phenomenon happening. And yeah, I would argue the meaningful phenomenon is the sensate organism's experiences, and the ethics is just a calculation of how to minimize the suffering and maximize the cessation of unpleasant sensation. And obviously, the simplest way to do that would just be eradicate the stupid feeling things because they're just negative value engines. They just run on perception of broken. They make a problem that needs fixing. I need is a problem. And the solution for I need in after once you allow evolution to make a real mess out of it, the solution to I need just ends up being I need to exploit, I need to consume, I need to kill, I need to destroy, I need to take. And that can't be done rationally. But yes, physics really has no direct relation to ethics. The relationship is that all science is a search for the truth. Okay. So it can't be really emphasized enough, this whole push-pull argument, that this is one of the key mistakes in physics that they totally invested in a pull um, theme, and that theme is just almost irrational as a starting point. You should always first they should have eliminated all possibility. They should have uh, extensively and exhaustively attempted to make push work before jumping on the pull bandwagon. It should have been a last desperate, like they should have just been totally fed up and exhausted trying to make push work and then concede, okay, well, let's try to do this pull thing. And that's not the history of physics. The history of physics is as soon as they were given an opportunity to go with push, they went with pull, because pull is like attraction and they like that word better than repulsion, something like that. Clearly a matter of convenience, not logic. So 300 years ago, a guy proposed particle gravity, and what's clear is it matches the inverse square law, that it creates a very good model of gravity. Now, it doesn't create a very good model of velocity in space, um, but that's because they just weren't, at the time, they weren't smart enough to convert it into a kinetic mechanism and realize that in a frictionless environment where things can't be broken, that there is no heat, there is no generation of any noise, or um, um, there's no force laws to overcome. That you can get rid of any um, momentum problem by realizing the school of fish is a school of fish, and it will go where the fish go. It's not made of. It's not a solid object. It's an object made of the little things themselves, and the little things don't have any resistance to moving freely in space. The bits you're made of are very capable of flying freely in space. Anyway, all right, so this is more related to the Ken type, the electric universe type of people, I think. This little section I wrote anyway. Active denial, I think. Active, okay, something active field of moving particles, gravitons. So active something, dense. All right, so that's the way you start. You start with an active, dense field of moving bits, and we'll call them quantons. And so they can have these two major flavors, gravity and magnetism. And then light being misunderstood as something distinctly different because we can see it, is really just another form of gravity, magnetism, light. Those three things belong in the same category. They have the same properties. And it's a misnomer to think of them as different things fundamentally. No, somebody faking using my name as an account name. So rude. The universe is partially pure electric, says you. I'm obviously disputing that the word electric even has a meaning. Okay, pure electric is electrons. If you don't know what an electron is, or you don't believe in them, you're kind of an idiot. And they have to roll through a conductor for the phenomenon of electricity to exist. Electricity isn't nothing, it's a something. And there's no evidence that the universe is pure electric. Well, again, electric doesn't equal energy. I mean, there's lots of things that equal energy. So, you know, I'm just saying you don't need electricity necessarily. There's nothing electric, let's say, about a nuclear bomb, or even, let's say, the exhaust from a rocket. It's not electric. I don't know what silly acronyms mean. Let me finish. No, I don't know what I'm going to bother with that. There's not much chance you can finish if all you can do is type 3 words and then hit enter. So, that doesn't really work for me. So you're going to have to try to type more than one sentence per line, or it's really going to become quite irritating. Yeah, whatever. He's actually me from the future. I come with advice. Yeah, sure. And I'm always indicating how receptive I am to advice. I mean, I'm always telling the people giving me advice. I'm always so grateful, and I know I always extend so much love and appreciation for advice because I'm always soliciting advice. Yeah, I'm being sarcastic, giving you a fair notice that fuck you is pretty much what I'm thinking. Fuck this guy. Yeah. I don't even know what the icon is. Let's see. There's probably no point. Like I said, we got 14 words in 6 lines. Oh, it's a nice looking chick of some kind. Hey, chickie poo. Some kind of fake one, no doubt. In 5 years, to become transgender porn star. Well, I don't think so. Transgender. I mean, does that mean I become a lesbian? I mean, I might become a lesbian. I mean, I might go for that. But I don't think I will be licking any willies. It's going to be a lot more than 5 years before I work my way up to that one. Don't see it happening soon. Anyway, we'll give him one more. We'll give him one more stupid remark, and then we'll be done with him. So hard to do science in this, in the middle of idiocracy. Such a burden. Anyway, okay, so we just have the field, just the quantons. And the forces, like I said, we kind of, the separation that people have, this separation in their head that somehow magnetism and gravity and light aren't the same thing. And they're fundamentally the same thing. I mean, you can see it in the fact that they move the same speed, that they always are this carrier of energy. When they're active, when their fields are on, when the light bulb's on, when the magnets being a magnet, and when gravity is doing its thing, stuff is moving, stuff is happening. Clearly, all the same thing, just in a different configuration. Slightly different too. Just the tiniest of difference makes a huge difference. Radio waves and visible light. They seem like very different things, and all you're really talking about is a frequency. Put them closer together, they're received by an electron as a different thing entirely almost. Invisible versus visible. They have an effect versus having no effect. But clearly, from our point of view, the idea of the frequency being a significant characteristic of, say, a bullet. If I was shooting bullets and I shot them one every second, and then I went and I shot them one every 2 seconds, you wouldn't say, hey, those bullets are fundamentally different. Those bullets are incredibly different. We'll call those bullets completely different things. So the ones going 1 per second are called bullets, and the ones going 1 every 2 seconds are called phildons. You wouldn't do that. That would be silly. And that's essentially what physics, unfortunately, has fallen for. It's it's been fooled into completely mislabeling the foundational elements of the structure and separating gravity, now it's bent space, magnetism, and light was a catastrophically unfortunate error. That's what we'll call it, an error. But it's hard to call it just an accident because it's so the way they made the mistake was so unscientific. Again, the two slit experiment, they didn't even try to come up with rational explanations. They just wanted to believe in the silly putty. They wanted something glittery and sparkly and mysterious. They didn't want something cold and simple and, oh, it's never mind. And that's unfortunate. That's tragic, as stated. Tragic for the science, anyway. All right, so we have in the big field of gravity, you have random polarization. So you have random frequency, random polarization, and I mean random in the equilibrium sense, not in any kind of rigorous randomness. Just in the sense that from our perception, it's going to look like entire chaos, even though it probably has some residual amount of memory, structure, shadow, echo, has some echo in it, but it's not echo we can detect, significant echo. Well, anyway, and then that creates an even pressure and in a sense, the gravitational push. And the push isn't a literal push. The push is an acquisition of momentum. Then when the graviton hits the material object, the electron, it reflects off of it, and that reflection causes a momentum exchange. The thing that was going this way goes that way, and the thing going this way goes that way. And that's an important distinction because those things are labeled by their polarization, and the polarization exchanges direction. And an exchange of direction is essentially an acquisition of direction when you do it with any lack of equilibrium. So when more things are, when you're having more interactions on one side of you that are reflections than you're having on the other side of you that are reflections, you'll end up being moved, accelerated by that process. Okay, so all this 300 years ago would have been called the Lesage. Well, 300 years ago it was the real French guy who invented it. Lesage was the guy who stole it 100 years later. But it's basically mock gravity, and it does explain as thoroughly as bent space can gravity. I mean, it's an accurate, it creates the same convergence and fits all of the mathematical equations that have been tested over time. Okay. So it's currently called mock gravity, and it's perfectly suitable in explaining gravity. And its only liabilities are ones that have to do with momentum outside of gravitational equations, and that is fixed by the kinetic nature of the interactions. Anyway, effects through acceleration. Nuclear parts of matter. So this is that sort of argument that gravity is a nuclear force. All the forces are nuclear forces. they affect parts of matter, not matter. They affect the bits inside of atoms, not atoms themselves. So electrons are accelerated, and protons are accelerated, and neutrons are accelerated. The bits inside are the things being motivated, uh, obligated to move, and their movement translates into the movement of the entire beastie. Um, and certainly that transmission of force um, is, um, I mean, it's always going to be spread throughout something material anyway because of the bonds, the magnetic field connections the things have. But clearly, the speed at which it accomplishes the task of causing the acceleration would indicate that the force itself doesn't need the secondary force to do the accelerating. So it's just a complex way to say that the force does move through the matter and is affecting the bits, not the matter itself. Gravity is not just bouncing off your skin, it's going through you and hitting a lot of your little bits. All right. Electrons. I don't know what this was. Oh, yeah, electron, protons, and neutrons. So those are the three atomic relevant material mechanisms. They're not particles, they're schools of particles. They're clumps of particles. And I would just point out, for the sake of the argument, that what's clear is that the polarization of electrons is inverse to the polarization of protons, and that neutrons are likely a mixture of the two, which ends up appearing as a neutral. And through the mechanism, through the interaction of those three things in terms of finding a balanced relationship to each other, that atoms are held together through a magnetic tension. Yes. All right. Darkness of shadow, intensity of gravity. I don't know if I need to get into that part, but that's just the standard argument that in a field of pressure, the pressure created by the movement, speed of light movement of the gravity, any two objects placed in that field will be pushed into each other by Mach gravity. And again, the argument isn't so much that this pushing force is a real push, it's just that it's a it's a push in the sense that reflections are the same thing as a push, but you're really accelerating. All right, production of invisible polarization. That's magnetism. Let's see, invisible to matter. So yeah, so the force being emitted by the one polarization electrons is a force invisible to the protons, and vice versa. The force emitted by protons is invisible to electrons, and that's the nature of the attractive force. It's basically an emanation of the pushing force. So there's no push in between the two objects, so then the external push pushes them together. So it's just breaking equilibrium is all that's really happening through the use of polarization. Do you think that the universe is flat? Well, I think that question is not worth much, to tell you the truth. I mean, I'm not big on this whole big universe calculations of its mass or where it's heading, or whether it's getting bigger or whether it's getting smaller. So I'm not terribly interested. I am thinking the fundamental, just as a side comment, the fact that these things don't appear to be changed in their direction, the momentum doesn't change direction. It's only through exchanging polarization. So technically, everything's moving straight lines and it never does anything else. And so the light that bounces off of my face here and you see in the camera, well, the actual momentum went straight. It went straight through me and went through the couch and went through the wall and went through the earth and it went on its way. And the only way you have to create some kind of bubble or some sort of reflector around the whole universe to be able to reflect the energy back into the universe. So theoretically, if you don't have a reflector, some way to bend or reflect the light back into the photons, the quantons, to contain them, if you don't have a container of some kind, then the universe is going to die. So yeah, you'd have to say it was flat then, right? Flat means dead. I mean, flat means it's going to run out of energy. All right, so yeah, so I think I did a pretty good job of just going through that little bit there, foundational bits. Um, all matter is movement. All material movement is a derivative of force speed. Yeah, I like that argument. So again, back to the fish thing. So when you see a school of fish moving, it looks like the school is going somewhere, but obviously it's just the fish going somewhere. So anytime you have movement in a material thing, this is just a derivative of fish moving the speed of light. So this is really just a combination of light speed, and it's just light speed in different vectors. And the fact is that in the period of time it took for the hand to move from here to here, more light went that way, okay, than went that way, a tiny bit more. And that's why the hand ends up over here. But it's just those simple little, it's all a derivative of stuff moving the speed of light. So even though this is moving so much slower than the speed of light, I can't even, like, a million times slower than the speed of light. This movement right here took 1 second, let's say 1 second. That's a million, well, it's 3 million times slower. Right? I went less than a meter. Let's say, well, I have to do a meter in 1 second, would be 3 million times a second to get to the speed of light. So you can just see how much slower we are than the actual fish inside of us. 3 million times slower. So yeah, so everything is just a derivative of the speed of force. Force makes everything happen. Force is the quantum moving the speed of light. Let's see. All force has one-dimensional mass. So yeah, this is a really important one. So right next to the push-pull argument is this mass argument. What is mass? And I think this is just too obvious. Okay, say if this was a photon and it's moving towards you. The idea is that it only has mass in the direction it's moving. So it's one-dimensional mass. You can't see a photon going, can't detect it going, can't in any way interact with it going. So from the other two dimensions, this dimension and this dimension, it's as if this doesn't exist. It only exists in this dimension, the dimension it's going. So the fish are one-dimensional, and they have one mass unit in that one dimension. Now the trick is mass, atoms, have billions of little fish in them, and there's fish going in all directions. So it's three-dimensional because there's fish moving in all of those dimensions, and they're being hit by the gravity and contained in the package, but they're all trying in a way to get out. They're all heading out, but the polarization is getting reflected back in. No matter where it goes, it gets reflected back in. It just can't really escape the package because of the pressure from the gravity. And so the little electrons just can't lose their fish. And they end up with a 3 dimensions because there's fish going in every single vector of every single dimension. And so mass is just having mass, and essentially the 3 dimensions is when we start to count it as mass. But the single fish have mass. They're the ones that create all the mass. So if you count the number of fish you have, atomic weight, that'll tell you how much mass you have in one-dimensional fish. Yeah, that's an adequate explanation. Why are physical laws, mechanics consistent? Well, that's like saying why is contradiction stupid? I mean, it's really the white space question is the important question. I mean, why can't contradiction be correct? And the point would be is because it's just fundamentally impossible for something to be to have 2 conflicting or contradictory properties. It can't be both on and off. Just the rules. You can't go the speed of light and some other speed. You can't weigh 100 pounds and 50 pounds. Just can't. You can't occupy. You can't occupy conflicting or contradictory facts at the same time. You can't possess them. It's just a rule. Well, whatever. I don't think it just says me. I think it says logic. I mean, it's a rule of logic, but I'm just saying I think you can do logic on the rules of logic and figure out that if you gave it any kind of thought at all, you can understand that, yes, 2 can't be 3. It just can't. It's 2-ness, can't be 3-ness. And you can sort of get that. But if you can't, that's your problem. Let's see. You are so depraved. Oh, gee, that's just not very interesting. Ah, you're talking about Emendum. Yeah. It's not really Emendum. He's cheating and lying. Yeah, I don't know. I guess maybe he's hitting you on the transgender porn star part. Maybe he thinks that's a depravity. But I think you are probably a horrible, awful, depraved pervert. Likely live a basement life, having evil little thoughts. Why do I have to explain myself? Well, I don't know. I think it's sort of an obligation when you say a statement like you're making a description. It seems to me, you should be able to justify your description. Just give an example. You could just say, because you're wasting people's time with infantile and vacuous rhetoric. Something like that. You're trying to stifle the progress of physics. Yeah. Heckling Einstein. Well, I don't even know what that is, but I'm not a lunatic, as will be proven, and you're an asshole, as will be proven. All right. So anyway, where was I before interrupted by the idiocracy? All right. All movement derivative of force, speed, and yes, mass is also just a matter of fish weight, and the fish only have weight in the one direction. They're moving the speed of light towards something, and you're only going to know the fish are there if the fish is heading right for you. That's it. And there's only going to be impact of mass when it hits you. All right, and matter has three-dimensional fish and moving in all three dimensions. That's what makes matter matter. Yeah, I think that's a good one. Let's see. Which is impossible. At one point you said you were from the future. Ah, yes, that is impossible. Well, physics says so, actually. See, to get to the future, you have to go. Well, I mean, if you go faster than light, you end up in the past. To get to the future, you have to go slower than. Well, I don't even know. Yeah, I have to think about that one. How the fuck would you get to the future? Well, no, the future is going faster than light, right? Yes, because you would get to the future before the light goes. Yeah. So the past is the one you can't get to. Yeah, that's the fuck that. That one's impossible. Yeah, I don't even know if it was an engineering feat. See, that's the trick of it. I mean, I'd like to say that I was profoundly brilliant and all that crap, but all I wasn't an asshole. You see, I didn't just sit there and make up fairies and accept fairy stories. So it was really just about the garbage out thing. So I just did the physics by saying, oh, these guys sound like they're full of shit. So let's just take their shit and slide it over here, which is the same thing as like taking God theory and you just slide it over there. And then all of a sudden you're saying, well, okay, how does this work? And you say, oh, yeah, well, these monkeys look like those monkeys, except a little bit different. And, we have parts inside of us that look like, stuff that we're not using anymore. And, porpoises have hip bones. Where they have those for? And so you start figuring out this evolution thing. You say, oh, evolution, that makes so much more sense. Shit, yeah, that God stuff really was silly. And physics just did the same thing. Physics just, you know, it keeps trying to make Jesus into God and, the wave, wave theory. They just keep trying to make waves into some, like, look, it's a wave, except it doesn't spread and it just stays right there, you know, except when it's Heisenberging or Huygensing, then it's really fucked up. I mean, that just sounds like the Holy Ghost or something. That doesn't sound like, anything rational. But one thing that always interests me is perpetual motion machines. Yeah, well, they're interesting. I have to admit, when I was 20, I was working as a machine shop, and I did have like 3 months where I actually indulged my boss guy thingy to sit there and try to talk me out of it because I had this invention, a wheel, and it was buckets, and the buckets would, use gravity, to be pushed down by water, and then the other side would slowly dump the water out and get lighter, and I kept thinking that I should be able to gain more speed than the momentum of the water by changing the location of the bucket. So if I move the bucket in towards the middle of the circuit, the circle. So if I had like a really frictionless way to move the bucket into the middle of the circle, the going up side could be really light, right? Because it's inside the circle. And so it's moving less distance. And well, anyway, so I did have I did fall for it for a little while, I have to admit, but I did grow out of that. But it does intrigue you. You do say, you look at it and you say, this maybe there's got to be a better way to pull some energy out of this. Because even magnets look that way. I mean, magnets are just they're so overtly saying, I have energy, but they don't. You have to move them. They just don't. They just have the ability to communicate position to something else. So you can move something else with a magnet, but you really can't make movement. You can only move this and force electrons to move in a wire or force a piece of metal to move, but you really can't steal movement. Can't get it for free. So anyway, I did find it interesting. In the future, Piro becomes an advocate for gay Muslims in America. Well, I think he already is that. Piro's a lunatic. Open borders. I mean, how can anybody rational say, I'm for open borders. Everybody should live wherever they want? I mean, it's just too stupid. I mean, unless you have like everybody, unless everybody's allowed to live in gated communities where you can just say, fuck you, you can't live here. you know, so yeah, let them only live in the gated community that allows the scummy foreigners. you know, yeah, that'll be really. Oh yeah, that's a beautiful vision of America. Segregation everywhere. An example of light bulb giving off energy powering itself. An example, a light bulb. An example, a light bulb giving off energy powering itself. Yeah, well, that one's really. I never had a vision of a self-lighting light bulb. So yeah. So anyway, I never. That I wasn't stupid enough to fall for that one. So yeah. So no offense, but yeah. I mean, light bulbs just always seemed obviously like they were using a lot of energy. Just seemed kind of obvious. They got hot and just like, oh yeah, you're not going to get that for free. So anyway, yeah, I think I covered almost everything here. I got all the dimensional stuff, and the rest of it's just the polarization argument for magnetism, which I sort of explained. Magnetism is just an extension of the proton-electron thing, the collection of polarization in segregated location, and it becomes a filter that essentially lets one force through and blocks the other force inversely for the two poles, which just magnifies gravity in a sense. So it's funny that they have the word magnetism is accidentally the same is accidentally, it's almost synonymous with the word of magnifying, and the two words have two separate derivations, but magnetism really is a magnification of gravity, which is quite coincidental. I mean, it just it's another reason why I must be right, because gee, that's just too cool. That magnetism is really magnified gravity. And light is just gravity with a frequency and polarization. That's it. The whole electromagnetic spectrum is just polarized gravity at a frequency. So I have exhausted my piece of paper. I could play some more Ken video, but I don't know. It doesn't really say anything else. It just keeps repeating the same thing. It's the same amount of same amount. But I mean, the whole force dynamics stuff of arches has already been dissected to pieces. So there's no point in me talking about it, and I'm not going to do an expert job, so I wouldn't even open my mouth on it in that sense. But I just know the fact is the way that arches make things stronger is that they distribute the force through the entire almost all the material is now involved in the support, where in the regular flat piece only this piece in the center gets the most of the force and very little of it spreads. And the arch is basically, instead of pushing all down, it's taking the force and pushing it sideways. So arches always have to have good supports on the side or they'll fail, because there's really, an arch is really just trying to become a straight line. It's so the force is horizontal versus vertical, which gives it some more advantage over something flat. But it's really just kind of a way of changing the center of gravity. I guess that's a way of thinking about it. It just spreads the center of gravity of the material. And so instead of having a focal point, where the force is maximized, the force is distributed across all, like I said, a lot more of the material. So it makes the center of gravity bigger, you could almost argue, I suppose. But I'm just saying that science is already written. And for Ken to make a video like he's adding something to the conversation when he added nothing, and where he ended up implying that weight has something to do with and like an arch somehow changes how much you weigh, which obviously it doesn't. So I mean, it's just a silly video. I guess that's another word I'll use in the title of these videos. I'll put silly maybe in the next one. So he'll be foolish and he'll be silly, and then he'll be a fake and a fraud and a phony and a coward. Definitely have to throw coward, and maybe I'll throw sissy in there. He is being quite a sissy. Big talk, no walk. Just scared of a skinny guy who didn't wear a shirt. I mean, my big offense was not wearing my shirt. I mean, the truth was I was naked, but I'm, from the video's point of view, I'm just not wearing a shirt. I mean, it really wasn't, it's hardly a deep and profound sin, especially when one considers it was, 98 degrees in my house. Well, 89 degrees in my house. And such, so forth and whatnot. All right, so we need some more participation from the the rabble, the idiocracy. I need some feedback, or I'll have to go. I'm tired, and I used up my notes. So anyway, I'm getting there little by little. I have to make a nice, clean, animated, graphically precise video and just go through it step by step, bing bang boom, an hour, and I'll give you a year's worth of college physics knowledge in 1 hour. And so, yeah, that in itself will be worthwhile, I imagine. And yeah, people are just so full of shit. I don't know, I just can't, I'm still trying to think of what the angle is, why people are so obsessed with turning everything into electric when electric is just about impossible to visualize. I mean, even when you know what lightning is, you still can't see it as what it is. I mean, a bunch of atoms, and then the electron flies off and they become ions, and then those excess number of electrons, are creating EMF, and then that magnetic force is affecting other atoms, and then they're going to be created into ions. And I mean, it's all very. So anyway, time lost transgender. Well, that doesn't do me any good. Get some rest. German Hebrew future transgender. Whatever, this whole German Hebrew thing. I really just don't quite get it. But whatever, I guess, lunatics will be lunatics. I just don't get it. Really understand any of it. I'm certainly got some German blood, I'd imagine, but it's also got some Irish and Italian. I have some Italian in me. you know. Uh, well, I don't know. Yeah, I'm definitely look, you'd be motivated too if you went out to just figure out why people were full of shit on the two slit experiment and accidentally found the unification theory. You'd be like, holy shit. I stumbled. It's like stumbling on a gold mine or something. You're just like, shit, I found something so incredible. Or it's like finding the bones of a dinosaur, holding a champagne glass. It's like, ah, I found something incredible. But it's still alive. Yeah, champagne. Tyrannosaurus drinking champagne. So anyway, just to clean things up, I think we will dispose of the poser faking his way through life, stealing other people's monikers. So, good night to Mr. Inmendum. Well, I have even more videos on the Inmendum channel. I got 3,000 something, but I've actually made the last 10 years. I've probably made close now to 5,000 videos, and they're not like 2-minute videos. They're all like 15 minutes or more, and on the Inmendum channel, they're all like a half an hour or more. It's a lot of video. And then I've done, I used to do live rooms every Saturday for 8 hours or whatever it was, 7 hours with a live room every Saturday. Ugh. But that got way too painful. So anyway, I am still seeking anybody in the audience. I do these rooms rather regularly at 12 midnight Eastern Standard Time. And if you'd like to come into the room and discuss physics and especially defend conventional physics, please just leave a comment or something, and I can give you the link to the room, and we can discuss it mano a mano, brain to brain. And I will sincerely attempt to understand, why you're convinced that such weakly evidenced conclusions are legitimate. So anyway, yeah. Well, strong will is just kind of a funny word, right? Because no matter what your will is, it's strong. I mean, I could have the will to sleep on the couch, and it'd be a strong will to sleep on the couch. No. Um, I'm, motivation is an interesting concept. I mean, I've always found life uncomfortable and troubling. So obviously, I've always been a find out why things are the way they are, trying to analyze things, try to find solutions. So I've always been someone, people would call me, they have a problem, they call me because Gary could sometimes engineer a solution. I was pretty good at troubleshooting, pretty good at finding a, what do you do? Your water pipe just broke or something. And, I'll be like, yeah, well, just find a broomstick and blah, 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 shove it in the hole, I'll, come up with some kind of, uh, something to do about the problem. Um, and, yeah, sorry, I was just thinking, the broomstick answer is only good for like really old pipes. The copper stuff, it probably wouldn't work. So anyway, it's probably not a great solution. So yeah, maybe I'm not too good at troubleshooting anymore. Um, Plastics. Just find a plastic bag, make it in a little ball, shove it in a hole, and tie a string around it. Anyway, something like that. So, but yeah, so I guess I'm motivated by a long felt tension with the uh, bullshit that is the common human perception. Yeah, something like that. All right, so it's kind of a slow night. Anyway, so till the next time when I will do further utterances on the subject of physics and assholes, tangentially related. Yeah. Anyway, till next time. Derivative of light speed. Yeah, that's all that is. It's a derivative of light speed.